Okay, so this is the first lesson on this section of the syllabus called carboxylic acid derivatives. And today, in this lesson, let's have a look at the structure of carboxylic acids, which of course you should all be familiar with from GCSE probably. Okay, so let's think ethanoic acid. So there's 2 carbons, and you have a carbonyl group and an OH. I started off with ethanoic acid. Methanoic acid looks a bit weird because it looks like this. So just got a hydrogen here, yeah. Methanoic acid is strange because it can be oxidized, because effectively you've got an aldehyde group there. So strangely, methanoic acid will give a positive test with Fehling's and with Tollens. No other carboxylic acids will do. Okay, so we're okay with this. Is the functional group, and you always use the oic acid as the suffix. You don't need to call it ethan 1-oic because of course it can only go on the end. Okay, so that's the basics there. Now obviously the one thing about carboxylic acids is that they are acids. Let's have a look at that. Okay, so carboxylic acids, acidic behavior. Okay, so what are acids? Acids are proton donors. So here we have a look here. I'm just going to throw the dog out because she's making a noise, chewing something. I'm back. Okay, so acids are H plus donors, right? And we can, so if we're going to be fairly strict about these things, let's put in water. So, and that's going to form CH3 COO minus. So it's lost. This is the acidic proton, right? Obviously the hydrogens from there don't go anywhere. And you're going to form H3O plus also. Quite often when you write this down, you will just write it as leave the water out, and just put H plus there. But it is important to realize that a minute. It is important to realize that they give the H plus to something else. They give it to the water. So you can see the water here is behaving as a base because it accepts an H plus, becomes that. I should also put in the this is an equilibrium arrow, really, isn't it? Because carboxylic acids are weak acids. Only a very small proportion of ethanoic acid molecules will actually lose a proton. Most of them stay like this in aqueous solution. It's just the odd one that does that, gives away that. Okay, so we'll have a little think, why are carboxylic acids acidic? And we'll just compare that to the case with alcohols. So if I just so if I've got ethanoic acid, that does lose a proton. Whereas if you've got an alcohol, let's think if you've got ethanol, ethanol has no tendency, doesn't happen to do, it doesn't do that. It doesn't lose a proton. Or why can ethanoic acid can do it? Well, there's a more complicated explanation, but what's good enough for us at the moment is to think, right, this carbon is going to be quite delta positive because you've got an electronegative element, oxygen, there attached to this carbon. And that's going to withdraw charge out of here. It's going to weaken this bond between the oxygen and the hydrogen, makes it easy to break. Another way of looking at it as well is that once you do have, once you form this negative ion, these charges don't really like that negative charge isn't really just sitting on the oxygen, because this is electron withdrawing and it will pull some of this negative charge away from the oxygen, makes this negative slightly less intense, makes it more favorable for that to form. That doesn't happen with the alcohol. There's no electronegative elements attached to the carbon. Okay, so a little bit more about, so just to think about carboxylic acid salts. So just if we go back to GCSE or whatever, we've got an acid, HCl, and we add an alkali to that, NaOH, we're going to form sodium chloride, which is a salt, and we're going to form water. Right, the same is true with carboxylic acid. So if I get ethanoic acid, so plus NaOH. Let's put the pluses and the minuses. So just to show you that the sodium is just a spectator ion here, really, isn't it? So we're going to form this negative ion, and that will be on the positive ion sodium, and we're going to get H2O. Obviously, in aqueous solution, that I've drawn that sodium very close to that ethanoate ion. It's not going to be anywhere near it, really. They're just floating around doing their own things. This would be called the ethanoate ion then. And the whole thing would be called, the whole salt would be called sodium ethanoate. Okay, so that's just a little bit of background information on carboxylic acids.